So you're welcome back. We've taken question 11 and we have gotten our answer as retina. So we move to the next question, which is question 12. And this one goes this way. It says the sound of an electricity bell dies down slowly when air is slowly pumped out from a bottle. Because of what? Let's take the option. I hope you understand the question. The sound keeps dying down. Before it was loud. As you pump out the air, the sound comes down. Till you can't hear the sound. Or if you can take a view, there is always a what? That hit on the gong. So let's take the option A. The wavelength of sound becomes greater in the bottle. That cannot be true. That should not be what will die down the what? The sound. B. Sound cannot pass through the bottle. Is that true? Let's take option C. Sound needs a material medium. Option D says sound can pass through a vacuum. Looking at what we have on the board, I'm sure you are guessing the answer already. Without air, definitely sound is not possible to be heard. So that tells you that option C is the correct answer. Sound needs a material medium, and that material medium is the air. And the question says it's slowly pumped out. So as you are taking out the air, the sound is dying down. The correct answer is option C. That's flowing from 2010. Let's move to the next question. This one says, given the progressive wave equation, y equal to 5 sine 2000t minus 0.4x. We have to calculate the wavelength. Now, what do you do first? You remember before now, I gave you a formula of the wave motion. You must know the equation so that you can compare with it. And this goes with this way. Let's write out what you have here. It says what? Y equal to what? 5 sine 2000t minus 0.4x. This is what we are having. So what do we do? We need to compare it to what we had earlier on. And that is the general equation of wave. And how does it go? It says what? The general equation says y equal to what? A sine 2 pi x all over lambda minus 2 pi ft. Can you still remember this? This is the standard formula to determine whatsoever you want to do under wave. This is the wave equation. So all we need to do, since we are looking for the wavelength, we just need to compare. Where is the wavelength? Wavelength is here. On that having what? X. That tells you we are going to compare these two guys. So we now have 2 pi x all over lambda equal to 0.4x. This is what we're having. And let's solve through. So we are looking for this. So we can cross multiply 2 pi x equal to 0.4x lambda. So x will definitely take x out. So we have our what? Our wavelength is still here. So we have 2 pi x equal to 0.4 lambda. So we need our lambda, so we divide through by what? By 0.4. But don't forget that our pi is here, and the answer is not in terms of pi. So you have to what? Substitute the value of pi, which is 2 by 3.142. Okay? Multiply by, okay, x is out, so we can't have x here again. So equal to what? Lambda. Straight away, we divide through by 0.4. That means this will be divided by what? By 0.4. What could lambda possibly be? That's question 13, and I have it with me as 12.4. If you analyze this, you're going to have 12.4. For the sake of time, so this is easily points in your calculator as video as you can see. So the answer is what? It's 12.4. That takes care of what? Question 13. Please, you must have a grip at your what? Your wave equation. If not, you cannot handle this question. From here now, my amplitude simply is what? 5 meters. So I move to the next question, and that's question 14. We have 15 questions for this segment, so we have 2 more now to go. So we take 14. Let's see what we have. It said the main factor which affects the speed of sound wave is the dash. So let's look at the options that we're having. Could it be the properties of the medium? Could it be the amplitude of the sound? Could it be the intensity of the sound wave? And the last option is what? Loudness of the what? Of the sound wave. So let's begin to eliminate them one after the other. I'll start from D. Loudness of the sound wave will not determine the what? The speed of the sound. It's just vibration that will define that. C. Intensity of the sound. That cannot determine the speed of the sound. Okay? Amplitude. No. You can, some of this instrument can have high amplitude, but in a short while it drops down. Definitely it cannot determine the what? The speed. So the answer that should be looking at the board is option what? A. Is the properties of the medium you are dealing with. So because each property differs, you can play the same sound from different materials, and one will go further than the other because of the property is having. So 2022, this question is a recent one. The correct option is what? Is A. So we're going to be taking the last question for this segment, and that's question 15. And it says, the lowest note emitted by a stretched string has the frequency of 40 Hz. Don't forget from what we had earlier, our fundamental note F0 for string is V over 2L. I'm sure you have not forgotten that. And now we are given to be 40 Hz. That is, this is now 40 Hz. What is now the question? He said, how many overtones are there between 40 Hz now and 180? So what do? Don't forget your F1, like I said before, is twice of what? F0. F2 is definitely what? 3 times of what? F0. F3 is what? 4 times of F0. So, since we have the F0 as 40, definitely F1 will suddenly become 40 by 2, and we have it as what? 80. We have gotten 1. Okay, the next one says F2, which is 3F0. We have now gotten to our 180. So, we have 3 by 40, and what do we have there? That's what? 120 Hz. That is the next one. Next, we have 4 by what? By 40, and that will give me 160 Hz. We have gotten the third overtone. Okay, that means we are not yet at what? 180. So we can get F4, which is 5 of F0. 5 multiplied by 40, all of a sudden we're now having 200 Hz, which is greater than what? Than 180. That means we cannot get to this point. The correct answer is from 1 to 3. So we're going to have 3 overtones. That's what you do in this case. Without wasting time, in a space of 10 to 15 seconds, you should have done the needful with this. So, with what we have so far, you could see that you are having a mixture of calculation and then more of theoretical question, base question that you need to think. So, not all about calculation, you must have grip at all the possible facts that exist. So, I know that you will do well going through this. Now, still part of the wave concept, we have about 5 questions here that we want to look at. Number 1 says, a guitar string is 75 cm. That's the length of the string. The question is, what is the what? Wavelength of its fundamental note. And you know in a string, the fundamental note, wavelength there, that's over 2 equal to L. This is what you have. This expression is very valid for this question. So what do you do since we are looking for the wavelength? All you do is to cross multiply, and then your wavelength will be equal to what? The product of 2 and the length. 75 here by 2 will give us 150 centimeters. So that tells you that your wavelength, which is 2L, is 2 by 75, and that's 150. That's the answer to the question. We have to determine just the what? The wavelength, not the fundamental note itself. But the note there is giving us the description on what to do about the number of lengths that we're going to have. So let's take number 2. It says, radio carrier waves are generated by causing electrons to oscillate rapidly in what? You know, there's going to be, when you talk about radio wave, there are lots of things that are involved. We're going to have the transmitter, we're going to have the receiver, we're going to have the microphone, and so on. I have an option here. Option A says microphone. 2, a television camera. 3, which is C, an antenna. And the last one says a transmitter. And the question is, radio carrier waves are generated by causing electrons to oscillate rapidly. Through what? And the options again, microphone, a television camera, an antenna, and the last option D is a transmitter. And definitely, for what? To cause electrons to oscillate rapidly, a transmitter must be involved. And the answer is the transmitter. Such question is what you should prepare your mind towards. Let's take number 3. It says, it's an applied question. Like I told you, you're going to have more of applied questions. It says, the colors seen in soap bubbles are due to what? Don't forget, we have properties of wave as we have discussed before now. We have interference, we have diffraction, we have refraction, and so many of them. But which of them describe the what? The colors that we do see when there is what? Soap bubble. What comes to your mind? Let me give you an option. I have option interference, I have dispersion, we have diffraction, and we have refraction. So what's the answer to that? The color seen in the soap bubble? The answer is interference. Interference. Follow up with the definition of the concept of interference, and definitely that will be your answer. I can switch the question this way again. That the color seen in the film of oil, we do see the film in oils. What causes that is still the concept of what? Interference. So, the next question here is question 4, and that's from 2007. And it repeated itself in 2022. Question 8 and 17 respectively. What does the question say? It said the phenomenon of light bending around an obstacle is what? So, is it reflection? Is it refraction? Is it diffraction? Is it interference? For light to bend around corners, the concept is definitely what? Diffraction. That is the bending of light wave around corners. So I will take the last question, that's question 5, in order to support this concept of light and wave in general. And it says, a perfect emitter or absorber of radiant energy is what? Indirectly, we are talking about the colors. Is it white body? Is it red body? A conductor or a black body? A perfect emitter or absorber. The color that does that often to absorb easily and to emit easily is definitely black. So, black is the correct answer to such question, and it's always repeating itself. I remember telling us that people doesn't paint their car black. Why? Because it absorbs heat easily. And we are in a tropic region. And you know what happened? More of heat to deal with. So let's take these questions and then apply it in other sphere. And it's always, going to help out during your exam. Thank you so much for your time. I hope we'll still have some other moments. Thank you.